We are going to talk about adding, subtracting, and multiplying radical expressions. The first thing we need to understand is that like radicals are radicals with the same index and the same radicand. So the like radical is 2 square root. Square root is the index of 2. Radicand is 7. Plus 3 square roots of 7. So they both are square roots. That's the index. And they're both have a 7 inside, so they're square roots of 7. That makes them the same radicand. So what you can do then is add the two numbers, the 2 plus 3, square roots of 7, get you 5 square roots of 7. An unlike radical is like 2 square roots of 7 plus 3 cubed roots of 7. So they both have a 7 inside, but this is a square root and this is a cubed root. So they will not add together. Another example, if it's square root of 3 plus square root of 2, they are both square roots, but they're not the same radicand. One's a 3 and one's a 2. So those would be unlike radicals. So let's go do some examples. So example 1, part A, we have 4 square roots of 11 plus 8 square roots of 11. So what that means is we can add the 4 plus the 8 square roots of 11 because those are the same square root. They're both squares and they're with an index of 2 and they're both 11. So square root of 11, and if we add 4 plus 8 we get 12 square roots of 11. All right, let's look at 5 cubed roots of 3x minus 7 cubed roots of 3x. Well, they're both cubed and they both have the 3x. So this gets us 5 minus 7 cubed roots of 3x. 5 minus 7 would be negative 2 cubed roots of 3x. And you don't always have to do this. I'm just doing that so you understand where the numbers are coming from. If we have 4 square roots of 5 plus 4 cube roots of 5. Well, they both have a 5, but one's a square, one is a cubed root. These are not like radicals, so it does not simplify. All right, if we have the square root of 20 plus 2 square roots of 45, these don't look anything alike, but those can be simplified. So we're going to do that. So 20, you just need to pick two factors. You can do 2 times 10, 4 times 5. It doesn't matter. I'm going to do 4 times 5. 4 becomes 2 times 2. So this now has that square root of 2 times 2 times 5. For 45, we can do 5 times 9. Could have done 3 times 15. It doesn't matter. You end up with the same prime factorization. So this would be plus 2 square root of 3 times 3 times 5. So we're pulling all of these. We've covered this before of how to simplify radicals. So we just put those in. Now we're looking, because it's square root, we're looking for a group of 2 of the same number in there. So we have 2 2's here. So this will become 2 square roots of 5. We have 2 3's here. So this becomes 2 times the 3 that we brought out, square root of 5. So 2 square roots of 5 plus 2 times 3 is 6 square roots of 5. Well, they're both square root of 5, so I can add my 2 plus my 6. That'll get me 8 square roots of 5. So that would be your final answer. All right, let's look at another one. So for part E, we have the cubed root of 54. It's not coming on very. Let's see if this will come in a little bit darker. Let's go back to it, a darker color. Minus 5 cubed roots of 16 plus the cubed root of 2. Well, these do not look anything alike except that they are cubed roots. So let's break them down. So 54 would be 6 times 9. 6 is 2 times 3. 9 is 3 times 3. So this will get us the cubed root of 2 times 3 times 3 times 3 minus 5. This is going to be 16. We'll go 4 times 4. 2 times 2, 2 times 2. So cubed root of 2 times 2 times 2 times 2. The cubed root of 2 is not going to reduce, so plus the cubed root of 2. So because it's a cubed root, we're looking for a group of 3 of the same number. So here we have a group of 3 threes. So this will be 3 cubed root of 2 minus 5. Here we need 3 of the same kind would be a 2, so times 2 cubed root of 2 plus the cubed root of 2. So 3 cubed root of 2 minus 10 cubed root of 2 plus the cubed root of 2. So now when we combine these together, we have 3 minus 10 plus 1. So 3 minus 10 would get us -7, plus 1 would get us -6 cubed root of 2. And that would be your final answer. And on any of these, you can always stop the video to see if you are getting the same answer that I am. Let's do another one. So for F, we have the square root of 27x minus 2 square root of 9x plus the square root of 72x. So again, we're going to break it down. 27 would be 3 times 9, which breaks down to be 3 times 3. So now we have the square root of 3 times 3 times 3 times x minus 2. 9 would be 3 times 3. So 3 times 3x plus 72 is going to be 8 times 9. 8 is 2 times 4, which is 2 times 2. And 9 would be 3 times 3. So now we have the square root of 2 times 2 times 2 times 3 times 3 times x. So one of the things to always remember when you're doing these, you can always multiply all of your numbers back to make sure you get back to your original number. So make sure you didn't leave off anything or you put in too many. All right, so here we're looking for a group of 2. So I have 2 3s that can come out. So that will get me 3 square roots of 3x minus 2. I have another pair of, or a group of 2 of a kind here, the 3's. So 2 times 3 square root of x plus, I'm looking for a group of 2 of a kind. So I have a 2 that comes out and I have a 2 3's that come out. So 2 times 3 square root of 2x. So 3 square roots of 3x. 2 times 3 will get me 6. So minus 6 square root of x. 2 times 3 is 6 square root of 2x. Well, none of these are similar as far as the radicand. They're both, or all 3 of them are square roots, but they are not, they don't have the same radicand on the inside. So the index is the same, but not that. So this would be your final answer. It will not simplify any further. Alrighty, let's go do another. So we have the cubed root of 24x minus the cubed root of 81x. And we need to break these down. So we just have 2 terms this time. So 24, we'll just go with 4 and 6. You could have done 2 and 12 or 3 times 8. So 4 becomes 2 times 2. 6 becomes 2 times 3. So we'll have the cubed root of 2 times 2 times 2 times 3 times the x that's still up inside. 81 is 9 times 9, which is 3 times 3. and 3 times 3. So minus the cubed root of 3 times 3 times 3 times 3x. So again, we're looking for 3 of a kind. So 1, 2, 3 2's comes out. So we have 2's cubed root of 3x. Here we have 3 3's that come out. So 3 cubed root of 3x that's left inside. Now, these are matching. They both are cubed roots of 3x. So we can combine that together, and 2 minus 3 would be negative 1 cubed root of 3x. And you can put the 1 in or just put the 1 in, or you can just put it as a negative sign. You don't have to write the 1 in this case. All right, let's look at another problem. If we have 7 square roots of 4 minus 12 plus the square root of 2. Well, the square root of 4 we know is just a 2. So this will be 7 times 2 minus 12 plus the square root of 2. Well, 7 times 2 is 14 minus 12 plus the square root of 2. Oops. That is a 12, not a 14 right there. Sorry about that. So 14 minus our 12 will get us 2 plus our square root of 2. And that would be your final answer. All right, let's look at another kind of problem. So example 2, we have the the square root of 3, this will be part A, times 5 plus the square root of 30. So here we're doing multiplication, and we're just going to multiply across. So square root of 3 times 5 will get us 5 square roots of 3. Square root of 3 times 30, that'll get us the square root of 3 times 30. We're multiplying on the inside of the radical. Because they're both square roots, we can do that. So 5 square roots of 3 plus the square root of 3 times 3 is 90. Well, now we need to break up the square root of 90. So I'm going to write this over here. Okay. Square root of 90. I keep hoping that's going to show a little better. I think it's the size of the pen. All right, so 90 is 9 times 10. 9 would be 3 times 3. 10 would be 2 times 5. So this would get us the square root of 2 times 3 times 3 times 5. Looking for a group of 2 of the same number. So that'll get us 3. Square roots of 2 times 5 is 10. So now we can come back over here. And this would be 5 square roots of 3 plus 3 square roots of 10. And that's not going to simplify because we have a square root of 3 and a square root of 10. So that would be your final answer. All right, let's look at our next problem. If we have the square root of 7x times the square root of 7 minus the square root of x. So square root of 7x times the square root of 7, that's going to get us 7 times 7 would be 49x. Square root of 7x times the negative square root of x gets us minus the square root of 7x squared. So we're just multiplying our insides. Well, the square root of 49, that's a perfect square, so we'll end up with 7 square roots of x. And x squared is a perfect square, so we end up with minus x square root of 7. And that would be your final answer. All right, let's look at our next problem. We have the square root of 5 minus the square root of 6 times the square root of 7 plus 1. So they're all square roots, so we can multiply them out. Square root of 5 times square root of 7 will get us the square root of 5 times 7 is 35. Square root of 5 times 1 would be square root of 5. Square root of 6 times square root of 7, so that'll be minus the square root of 42. And then the square root of 6 times 1 would be square root of 6. Now, if we look at our numbers for 35, we had a 5 and a 7. Those are the prime factorization. It's not going to get any simpler. Square root of 5 is a prime. Square root of 42, that's 6 and 7. 7 is a prime, and 6 is only 2 times 3, so it's not going to reduce at all, and neither is square root of 6. So this would be our final answer. All right. Let's look at our next problem. So we have 10 square roots of x minus 2 times square root of 7 plus, oops, sorry, I combined two problems together. So we have 10 square root of x minus 2 times 14 square root of x plus 3. All right, so we're going to do the same process here. We have 10 times 14, get us 140. Square root of x times the square root of x will be the square root of x squared. 10x square root of x times 3 would get us 10 times 3 would be 30 square root of x. Our next term is negative 2 times 14, so minus 28 square root of x. And negative 2 times 3 would be negative 6. So now what we're looking at is these two terms here, both are square roots of x, so it's just like any other foiling situation or distributing where we end up with 4 terms. These will actually combine. So square root of x squared will be x, so we'll have 140x or 30 square root of x minus 28 square root of x will get us 2 square roots of x and then minus 6. And that would be our final answer, because nothing else will combine. All right, our next problem, we have square root of 10 plus x squared. So remember, it's the same as we've done before. This will be the square root of 10 plus x times the square root of 10 plus x. So it's the same thing as we've done in the past. It's just we have square roots in there. All right, so square root of 10 times square root of 10 will get us square root, and we can kind of cover up that one right there. So that gets us the square root of 100. And then square root of 10 times x gets us this, the x is on the outside, so x square root of 10, x times square root of 10, and x times x. Well, the square root of 100 is 10. These, again, are like terms. We have x square root of 10 plus x square root of 10 will get us 2x square roots of 10 plus x squared. Now, 10 will only break down to 2 and 5, and so we can't reduce the square root of 10, so this would be our final answer. And we have one more problem. We have 5 times the square root of 6 minus 4. So again, we're just distributing. So 5 times the square root of 6 would be 5 square roots of 6. 5 times negative 4 would be minus 20. Square root of 6 is only 2 times 3, so that won't reduce. So this would be your final answer. And that is how you multiply, add, and subtract like radical.